one-dimensional truss element problem. So it consists of 9 bar truss are there, which is as shown in figure. We are going to analyze this truss element by using ANSYS software. From that, we can find the nodal displacement, stress in the each member, and the reaction at the supports. The truss material is considered as steel material. For that, Young's modulus is 2 into 10 power of 5 Newton per mm square. Poisson's ratio of the steel is 0.3. The area is 3800 mm square. The total length of the truss element is 1200 mm. The point load is acting on the truss element, which is as shown in the figure. ANSYS multiphysics utility menu. First, initially select preference, structural. OK. Next step is go to preprocessor, element type, add element, add. Select element type as link. Click OK. Then close this element type. Then minimize this element type. Then for this truss element, we need to assign a real constant. That is, we need to provide a area of the truss element. Real constant, add, again add, click OK. So here we need to enter the cross-sectional area. So for this problem, the cross-sectional area is about 3800 mm square. Then click OK. Then close this. And next one is need to assign a material properties. Select material properties, material model, structural, linear, elastic, isotropic. The Young's modulus of the steel is 2 e power 5 Newton per mm square. Poisson's ratio is 0.3. Click OK. Then close this. Now we need to go for modeling. Modeling, create nodes, inactive CS, create a node. So for first node, enter the node number as 1 and enter the x, y, z distance as 0, 0, 0 in order to create a first node at the coordinate system. Then click apply. Second node, we need to assign the x distance is 200 mm, x distance 200 mm, y distance 420 mm. Enter the node number as 2, x distance 200 mm, and then y distance 420 mm in order to create a second node. Then click apply. Third node, node number 3. For that, x distance 400 mm. So this is considered as third node. Node number 3. Enter the node number as 3 and the x distance 400 mm. Y distance 0. Then click apply. Enter node number as 4. So this is the node number 4. For that, x distance 600, y distance 420. X distance 600, y distance 420. Click apply, and then fifth node, node 5. Further, this is the node 5. Node number 1, node number 2, node number 3, node number 4. This one is a node number 5. For that node number 5, the total x distance is 800 mm. Y distance 0. And click apply. Next node is, this is the node number 6. For that, the x distance is 1000 mm. Y distance 420 and click apply. And finally, we need to assign a node number 7. So enter the node number as 7, x distance total 1200, y distance 0. Finally, click OK. So for this problem, we have created node number 1, node number 2, node number 3, node number 4, node number 5, node number 6, and node number 7. So totally it consists of 7 nodes for this truss element for a one-dimensional truss problem. So here we are created a 7 nodes are there. For that you need to connect a element auto numbering through node. Select first node and second one. Click apply. Similarly for second and third, click apply. Third and fourth, click apply. Select 4 and 5, apply. 5 and 6, apply. 6 and 7, apply. Then again I have to connect with first node to third node. Okay, and then third to fifth, then apply, and then fifth to seventh. Apply. 2, 4, apply, and 4, 6. Okay, now we have finished modeling, and then we have to go for this applying a boundary condition. For that, go to solution, define load, apply structural displacement on nodes. Select this node, then click OK. So here all the degrees of freedom are arrested at this left side. Here it is movement in a x direction. So now we have selected this one for that left side. For that left side, there is left side node is fully arrested. So select all degrees of freedom, enter the displacement value as 0, then click apply. So at node at the 7, it should be the displacement should be in a x direction. Only in a y direction is arrested. Then select uy, enter the displacement value as 0, then click OK. Now we need to apply a force. Here in this problem, here at node 2, the downward force is acting, and as well as the x direction force is acting in a negative direction. And node 3, 210 kilonewton load is acting. Node 5, 280 kilonewton load is acting. Node 6, 360 kilonewton load is acting in a downward direction. And finally at the node 7, 300 kilonewton load is acting in a x direction. Solution, define load, apply structural force on node. Select the second node and click OK. Select direction as Fy, which is in a negative direction. So select, enter the value as minus 280 E3. Click apply. Then select second node. Select Fx 210 E3. Then click apply. And then we need to assign a node at 3, load value at node 3, that is 210 kilonewton. Select node 3, click apply, which is in a negative in a Fy direction. Select Fy. So since it is in a negative direction, so then click apply. Then select node 5, click OK. That is also in Fy direction. The value is 280 kilonewton. Enter the value as 280 e power 3. Then click apply. And at the node 6th node, 360 kilonewton load is acting in a downward direction. Select node number 6 and click OK, which is in a Fy direction. Enter the value as minus 360 E3 and click apply. And finally select the 7th node, click OK, which is in the FX direction. There is 300 kilonewton, enter 300 E3, click OK. So here we have completed all the boundary conditions, which is as given as per the diagram. Solution: solve current LS, close this window, and then click OK. So here I get the simulation is done. And close this and minimize. So now we need to go for general post processor, plot result, deform shape, deform plus undeform, click OK. So here it is a displacement for this particular load. So the maximum displacement is 1.16845 mm. In order to get this file, go to plot control, write meta file, inverted to white or black, save type as Windows media file, save type as Windows media file, enter the file name as displacement. Save this data. Then contour plot, nodal solution, degrees of freedom, displacement vector, and click OK. So here it is a displacement vector. In order to get a deform plus undeform shape, so here it is a displacement vector. Here it is a displacement vector of a deform plus undeformed edges. By saving this file, go to plot control, write meta file, inverted to white or black, enter the file name as displacement vector. Save as a type Windows media file. Save. In order to get in the 3D view, go to plot control, style, size and shape, select the display of element. Select display of element and click OK in order to get a 3D view. So since it is in the front view, select isometric view, and once replot it, you can get the 3-dimensional shape of the truss element. For getting the nodal displacement value, list, result, nodal solution, displacement vector. So here it is a displacement vector of a 7 nodes. Save this file, save as, enter the file name as displacement vector list. List, result, reaction solution, select items to be listed as all, then click OK to get a reaction solution of a node at 1 and node 7. Save this file, enter the file name as reaction solution. Meanwhile, to get a stress plot, select list, result, elemental solution, select stress, select one way stress, and click OK to get a stress plot for all 11 elements. So for element number 1, the equivalent stress is 174.93. Similarly for up to 11 elements. Save this file. File, save as, enter the file name as stress list. I hope this video will be very helpful. If you have any query or comment, mention in the comment box. If really this video will be very helpful, kindly put a like, share this video with your friends. In order to get a further update, subscribe Simulation Engineers YouTube channel. Thank you.